Hello everyone, myself Sai Prasad, a lecturer in Allahabad High School in the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with our chapter Probability. What did we learn? We had a basic introduction about what is probability. Then we learned the basics of all the definitions like exhaustive, exclusive events, right? Then we learned the definition, the classical definition of probability and the basic theory about that. Fine? Okay. Today we will discuss few basic questions of probability, then we'll start our first theorem. Okay, now see here. The question is given as two dice are rolled. Let us start directly from our 12th class level. Let us not go and revise all those 9th or 10th class things. Fine. See here. Two dice are rolled. I am directly going to two dice. What is the probability that none of the dice shows a number 2? Okay. First, let me know, if there are two dice, how many number of outcomes do you expect? Tell me. Let us say a first die has an output of 1, 2, 3, 4, 5, 6. Right? Similarly, the second dice also will have the outcomes 1, 2, 3, 4, 5, 6. Yes. So, if I throw two dice simultaneously, then for first dice, if it gets an outcome 1, the second dice can have an outcome of 1, 1, 1, 2, 1, 3, 4, 5 and 6. Is it? What are the outcomes? Just tell me. Outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Right? What if the first dice gets 2 and the other dice will have 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. Clear? Similarly for third, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. Similarly for 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5 and 4, 6. And the next 5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. And the next 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. Total how many outcomes are there? For 6 numbers on the first dice, 6 more numbers on the second dice, that is 6, 6 are total outcomes are 36. Is it? Then the question he is asking is none of the dice shows number 2. Okay? None of the dice shows number 2. Therefore, favorable outcomes. How many? Without 2, we have to add 1, 2, 3, 4, 5 and the next 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25. Right? Or else you can simply write like he is telling that none of the dice shows the number 2. So you can just take the number of cases in which it is showing dice 2. Right? How can we tell is this 6, right? 6 and this 5. 1, 2, 3, 4, 5. 6 plus 5 is 11. 36 minus 11, 25. Did you get? So, the probability that none of dice showing 2 is 25 by 36. Is it right? Did you understand? So this set, whatever we wrote now, I am not going to write from next time. Clear? As of now, since it is for the first time we are doing this problem, I have written. So how did we write? For first set, if the first die shows 1, then the second dice can show 1, 2, 3, 4, 5, 6. If the first size shows 2, it can show 2, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Similarly for 3, for 4, for 5, for 6 will have total 6 sets. It will have 36 number of combinations. Right? Fine. Look at the next question here. What's the probability that the non-leap year contains 53 Sundays? A non-leap year, what does that mean? How many days do we have? We have 365 days, right? Out of which we will have 7 days a week. So just calculate how many weeks do you have? 7 5s are 35, 15, 7 4s are, 7 2s are 14, 1 is left, 0, 7 1s are 7, 3, somewhat around 52 point something. So just multiply 52 into 7. How much do we get? 14, 35, 36, 364 days plus 1 day. So I can write it as 52 weeks plus 1 day. Clear? Then he is telling that a non-leap year should contain 53 Sundays. So what does this mean? This 1 day should be Sunday. So obviously the probability of getting a Sunday here is probability of getting 53 Sundays is 1 by 7. Clear? What if we ask you only 52 Sundays? So what does this mean? Probability of getting only 52 Sundays is, out of 7 we should not get Sunday on this 1 day. Did you understand? 52 weeks ko we should have 52 Sundays, but this day should not be Sunday. That out of 7, 1 day has to be removed. So how many days we have? 6 days. So the output will be 6 by 7. Is it clear? Did you have a clarity? Fine. This is a non-leap year. What if it is a leap year? A leap year, then we'll have, for 365 we'll have 52 weeks plus 2 days. So here the outcome will be 2 by 7, here I get 5 by 7. Did you understand? Is it clear? Fine. These are the basic questions to understand the basic theory and the meaning of probability. Shall we start the theorem now? Let's do. The first theorem we are going to learn in this chapter is addition theorem on probability. What does this mean? What is this addition? Why do we need to learn this? As you all know that in sets, if I have two sets A and B, then n of A union B can be written as n of A plus n of B minus n of A intersection B. Isn't it? What does this mean? If I say I have two sets, okay, if there is no kind of joining, which means if I say there is no intersection, then I can tell that total number of elements is equal to sum of this element plus this element. Isn't it? If I have any kind of intersection between these two sets, so what does this mean? We have to add these two sets and subtract this area, because this is repeating 2 times, right? That's what this formula indicates. N of A plus N of B minus N of intersection B. What if it is in the probability case? It is also of same case, that is the probability of union of two events is given by the probability of A plus probability of B minus probability of A intersection B. Right? This is nothing but addition theorem on probability. So how do we prove it? Okay, let us take two cases, that is when joint and when disjoint. Okay, let us take disjoint first, where A intersection B is equal to 5. Okay, what is probability formula? That is number of favorable conditions by total number of conditions. He is telling that the intersection B itself is 5. What is probability of 5? There is no element at all. Obviously, the probability of A intersection B is equal to 0. Clear? So I can simply write the probability of A union B is equal to probability of A plus probability of B. Yes or no? If this is a sample space, if there are two events, event A and event B, then the total probability can be written as probability of A plus probability of B. Right? Then if I write it as P of A intersection, or else let me write it as minus 0. There is nothing to subtract. Can I write 0 as P of A plus P of B minus P of A intersection B? Right, that's it. This is simple theorem. You need not going to deep mathematical analysis of that. It is just a theoretical statement. I will say that P of A union B is nothing but P of A plus P of B. That's it. Because there is no kind of subtraction, or there is no common thing. So just I will write as minus 0. 0 is nothing but P of A intersection B. Right? Let us say this as case 1. Let us take case 2. Right? What do we do is, we will just write it as this case. It is not equal to 5. So A intersection B is not equal to 5. So there is some kind of parameter. So what do we do? That is, we will just write P of A union B factors and everything. Okay, how do we write? Tell me. That is, P of A union B can be written as P of A union. Can I write B as B minus A? Yes or no? Yes. So this is nothing but A union B minus A. He has removed this particular part A and this B minus A. We can write like that. Yes or no? So this is my B union A. So let me separate it. P of A plus P of B minus A. Yes. Fine, right? Fine. Next, can I write A as A union A intersection B? Obviously. Instead of A, I will write it as A union A intersection B. Right? What is this? This whole area. That's it. So let us write it as P of A plus P of B minus A intersection B. So let us separate it. P of A plus P of B minus P of A intersection B. This is nothing but P of A union B. Are we able to prove this? Actually, it is simple to understand, but difficult to remember all the steps. So better just look at here. A union B is equal to P of A plus P of B minus P of A intersection B. So let us take two cases. One is disjoint set and one is joint set. Disjoint in the sense, the intersection of two sets is always an empty set. So the probability is always 0. So I can simply write it as the probability of A union B is nothing but probability of A plus probability of B minus 0. 0 is nothing but P of A intersection B. Isn't it? Fine. The next thing, they are intersecting. So let us say A intersection B is 5. Then P of A union B can be written as P of A union B can be written as B minus A, right? And the next, let me separate these both. Again, A can be written as A intersection B. So then P of B minus P of A intersection B. This is our addition theorem on probability. Is it clear? Did you understand? Fine. Shall we move on to the next problems of addition theorem? Look at the question here. He gave, find the probability of drawing an ace or a spade from a well shuffled pack of 52 playing cards. Just tell me how many ace or spade do we have? Do we have any idea about that? Yes. First, just tell me there are 52 cards, right? Out of which there are half black, half red, isn't it? So out of this 26 black, 26 red, we again have two more parts, each of 13, 13, 13, 13. What are they? Those are, in black we will have spade, club, diamond and hearts. Is it right? Then in each combination we'll have 13 cards. What are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And the next A, J, Q, K. Is it right? These are the 10 numbers we'll have A, J, Q, K, right? Then he is asking us to find, did you understand? So we will have, out of 52 cards, 26 are black and 26 are red. Out of 26 we'll have spade 13, club 13. Out of 26 red we'll have 13 diamond and 13 hearts. Out of which we'll have 2, 3, 4, 5, 6, 7, 8, 9 up to 10 and A, J, Q, K. A is simply called as ace, J is jack, Q is queen and K is king. You should know all these. Just this is a kind of revising. Then he is asking us to find an ace or a spade. Okay, let us say event ace as A. How many number of A's do we have? Let me write it as a total number of samples is nothing but 52. Okay. Then let us consider A's as A. How many A's do we have? 1, 2, 3, 4. Okay. Then the probability of getting an ace is 4 by 52. Clear? Next, let us talk about spade. How many number of spade do we have? Spade we will have 13. Clear? Then the probability of getting a spade is 13 by 52. Clear? Is there anything common between spade and ace? What? In spade also we'll have one ace. So the common, that is the combination or simply the common thing is 1. Okay, let me write it as n first. Then the probability of A intersection B is 1 by 52. Is it right? Now if I substitute in the formula, the probability of ace or spade is given as P of A plus P of B minus P of A intersection B, that is 4 by 52 plus 13 by 52 minus 1 by 52. How much is it? 13 minus 1 is 12, 12 plus 4 is 16 by 52. 4 4s are 4, 4 1s are 4, 4 3s are 12, which is 4 by 13. This is my answer. Is it clear? Did you understand? Now look at the next theoretical kind of question. This is A complement intersection B complement. What is this? Can I write this as P of A union B whole complement? right? By De Morgan's law. You should remember this. You would have studied in your 10th class, but remember this formula. A union B whole complement is equal to A complement intersection B complement. This is De Morgan's law. Clear? So by that formula I have written like this. Now just tell me A complement intersection B complement is equal to P of A union B whole complement can be written as 1 minus P of A union B. Why? If you remember, we wrote like, we don't even have space. P of A plus P of A bar is equal to 1. Is it? So I can write P of A bar is equal to 1 minus P of A. Yes? Now see here, that is nothing but 1 minus, what is P of A union B? P of A plus P of B minus P of A intersection B. Just write everything, 1 minus to minus plus P of A intersection B minus P of A minus P of B. That is what they asked us to prove. Is it right? Did you understand the theorem and the problem based on addition theorem? Right? Is it fine? Okay. In the next session, we'll discuss few more problems on this theorem and we'll go to next theorem. Clear? Fine. This is for today. Let us meet in the next session with the more problems of probability. Thank you.